In this problem, n is odd integer greater or equal to 3, and a cosine 1 over square root of n is equal a multiple of pi. Now, this factor here, we want to prove is irrational. Of course, a typical way of proving something is irrational is proof by contradiction. That is, you assume k, the coefficient is rational, that is, a ratio of two integers p and q, relative prime, q non-zero. What we have here is arccosine 1 over square root of n equal this ratio is rational ratio, assume. Let's call the whole thing is alpha, right, in radian. So by definition of arccosine, cosine alpha would equal 1 over square root of n. We don't like square root of n. We want to get rid of it by using the double angle formula, cosine 2 alpha. If you do the math, it's going to be negative n minus 2 over n. Alright, so it's easier to work with integers. Now notice that alpha here is equal to this ratio, so which means q alpha equal p times pi. How about 2 q alpha, right? That's equal to p times 2 pi, right? So what we have is the cosine of this quantity here, cosine q times 2 alpha, is multiple of 2 pi. Of course, the value will be 1. So we want to prove by contradiction. We want to have a contradiction somewhere. You may get stuck, right? However, what we need to use is what's called Chebyshev polynomial, right? So let's look at the Wikipedia page here. So it's basically a sequence of polynomial related to cosine and sine. That is Tn x. So basically, a Chebyshev polynomial of the first kind, T sub n, is defined as what is a polynomial in terms of cosine theta for cosine n theta. And similarly for the second kind, that is u sub n, and that is for sine n plus 1 theta, what is the coefficient in terms of cosine theta times sine theta, right? So there is some recurrence relation for the Chebyshev polynomials, right? So there is recurrence relation here. We're not going to derive the recurrence relation here. Might do that in a different video, but let's go back to the slides here. So the first few polynomials are as follows, right? 0, of course, is 1, and 1 is itself cosine theta, and cosine 2 theta, we know that 2 cosine square minus 1, right? And 3, you can use the trig formula. Eventually, you can get this. And in an earlier video, we derived T7 cosine 7 theta equals 64 cosine theta 7th power, and that's the polynomial, right? All right, one thing you noticed is that T7 here has leading coefficient of 2 to the n minus 1's power. That is 2's power, right? 2 to the first power, 2 to the second power, 8 is 2 to the third, 16 to the fourth, and 64 is 2 to the sixth. Now, go back to what we have so far. So we assume this is rational, and then we use double angle formula. We claim that cosine q times 2 alpha is going to be equal to this. So which means cosine 2 alpha is going to be the roots of this polynomial, Chebyshev polynomial of order q, right? So that is cosine 2 alpha is the root of this one, right? Slightly different than the typical polynomial, we have minus 1. The fact that you minus 1 does not change that this is the integer coefficient with the leading factor of 2 to the q minus 1's power. And cosine 2 alpha is this is a rational number. So we first notice that this is a root, right? And we notice that this is a rational number, and n minus 2 and n are co-prime, n is odd. And tq is leading coefficient of 2 to the q minus 1. How do we have a contradiction? Use what is called the rational root theorem, basically saying that for integer coefficient, right, of polynomial like this, and if you have a rational roots p over q, then q must be an integer factor of leading coefficient. P must be a factor of the constant term a0, right? So here we're going to use this fact here. The denominator here of the root must be a factor of the leading coefficient. So which means the denominator here is n. N must be a factor of 2 raised to the q minus 1's power, right? However, that's not possible because this only factor here is 2, but n is an odd number greater or equal to 3, right? That's a contradiction right there, so which means our original assumption is false, that is, the ratio is irrational. So we have the proof, that is, use proof by contradiction, we conclude that arc cosine 1 over square root of n cannot be a rational multiple of pi. Okay, for example, 1 over square root of 3, square root of 5, so on and so forth. There must be irrational multiple of pi. Right? We will talk about more about Chebyshev polynomial and other interesting math problems. So please like, share, and subscribe to the channel.